Hey guys, welcome to CrownSmart. In today's class, we want to differentiate tan x. Now, we're not using first principle, and we know that this is the definition of your first principle. So now we know that our f of x is already tan x. Then our f of x plus change in x is equal to tan x plus change in x. Okay, now we go back to our definition. F prime of x is equal to the limit as change in x approaches 0. Now, what is our f of x plus change in x? We have this as tan x plus change in x. So this is what? Tan x plus change in x minus, what is our f of x? Tan x all over what? Change in x. Okay, now this is equal to the limit as change in x approaches 0. Now, what is our tan x plus change in x? Our tan x plus change in x, remember our identity. This will be tan x plus tan change in x all over 1 minus tan x tan change in x. So if you remember your trig identity, your tan x plus change in x will give you this minus your tan x. I'll put it over 1. So everything is all over your change in x. Okay, so what happens next is we simplify this. Now, simplifying this, I have to simplify this one. Okay, so this is equal to the limit as change in x approaches 0. Now we have this as our let me simplify this. Okay, let me take this as 1 over change in x multiplying, because this is this over this, so it's the same thing as saying this times 1 over this. So I'll take 1 over change in x times, now simplifying this, the LCM of this and this is 1 minus tan x tan change in x. So this will give us 1 into this is this, so this times this will give us tan x multiplied by 1 minus tan x tan change in x. Okay, now this cancel, this is 1 times this will still give us tan x plus tan change in x. Okay, so this is equal to the limit as change in x approaches 0. Now we have this as 1 over change in x multiplying. Now if I open this up, I'll have this as tan x plus tan change in x minus tan x minus, okay, plus, because minus minus here will be plus, tan square x tan change in x. I just open up this bracket. Okay, now everything is all over 1 minus tan x tan change in x. Now this is equal to the limit as change in x approaches 0. Now we have here as tan x and we have here as minus tan x. If you bring them together, it's 0. So we have this as 1 over change in x times, this is tan change in x plus tan square x plus, no, tan square x tan change in x all over 1 minus tan x tan change in x. Okay, now this is equal to, okay, I'll factorize tan change in x outside. So this is the limit as change in x approaches 0 is 1 over change in x. Now factorizing this outside, I'm going to have tan change in x all over 1 minus tan x tan change in x. Okay, now what to be left with is 1 plus tan square x. Okay, I factorized this one out. Okay, now the reason why I factorize this one out is so that I will leave 1 plus tan square x outside. Okay, so that I'll be able to apply the limit on this. Now this is equal to, if we multiply this thing downward, this will still give us the limit as change in x approaches 0, we have this as tan change in x all over change in x minus change in x tan change in x. Okay, now everything here is multiplying 1 plus tan square x. Now observe, you see this is a special limit. Okay, it has a proof. Okay, I'm going to show this in my other video, how to show the do the limit of this. Okay, so this has a limit, and the limit of tan change in x all over change in x minus change in x tan change in x as change in x approaches 0, this gives us what? 1. This is a special limit. So the limit of this is 1, and it has a proof. I'm going to show it in my other video. So since we know that the limit of this is 1, we put this as 1 times 1 plus tan square x. Now this is equal to 1 plus tan square x. Now remember our trig identity. 1 plus tan square x is equal to what? Sec square x. So therefore our f prime of x is equal to what? Sec square x. So if we differentiate tan x, we have what? Sec square x. Thank you very much. Please do not forget to subscribe. Thank you very much. Please subscribe, very important. Thank you very much.